Okay, I believe this is the last video lecture series, the last video lectures for this Arduino video lecture series. Okay, again, in this video lectures, I will give some or several examples of how to use the output port for Arduino instead of using LED. And again, in general, the output itself can be categorized into these three groups: visual output, physical output, as well as audio output. And now let's first go to the visual output. Okay, instead of using LED, there are several examples of visual output. One of it, okay, there's a three example that I show here in this slide. Okay, you can use what we call as a NeoPixel rings. Okay, it's look like the LED, but it's look like a set of LED in one ring. And then we also have a 7-segment and as well as LCD monitor, which is this one. Okay, I will not discuss the code in detail. This one you need to explore by yourself, but I will do the demonstration to you of this three circuit or these three module in Tinkercad. But you need to explore by yourself how actually the code is, how the code what is the code that operating these examples. Okay, in Tinkercad you just search NeoPixel. Okay, once you find the NeoPixel, you just take the one that with Arduino, which is this one. Okay, of course in this example, the NeoPixel, it's not in the ring form or circle form, it's in line form. So this one you need to check by yourself how actually this code is functioning. Okay, how the code is functioning. I just show you the simulation there, how the NeoPixel is work. So it's look like some set of LED, and you can change the color. So that is the NeoPixels module. Okay, normally you use this one for some interactive project or giving some notation to the user by giving different type of colors there. It will give some different notation to the user. So that is one of the example or several example that you can use these NeoPixels. Okay, but later you need to explore by yourself how the codes there. Okay, but just open the code and then you see how the code is look like. Okay, this is the code there. And next, 7-segment. Okay, how about 7-segment? Okay, for 7-segment, again you need to write here 7-segment. Yeah, that is 7-segment. But unfortunately, there's no example of 7-segment with Arduino. Okay, you only have 7-segment there. So of course, for this one I give you, I try to manipulate. I try to manipulate our LED blinking circuit. Instead of using the LED, I connect my port with 7-segment just to see whether this 7-segment is working or not. Okay, let's open the example that I have created that related to 7-segment. Okay, this is my examples. As you can see that this is our 7-segment, and then actually this is the LED blinking circuit. The difference is that I remove my LED, I change it, and then I replace it with my 7-segment. So if if you see the code there, okay, it's a normal LED blinking code where it will when when you give a 5 volt, the LED is turned on, and that's why you see the LEDs, built-in LEDs pin number 13 here is turned on when the LED is, when the digital write high, and then we have delay 1 second before we turn off the LED back by applying this, by executing this digital write LED built-in low. Okay, this is a LED blinking code. Okay, I just replace that with 7 segment. Okay, so that's why you can see this segment is blinking, because I connect my wires there into this port A there. A is represent this segment. Okay, that one you need to explore by yourself, because you need to know this is A, this is B, this is C, so then you can identify which port to be on. But this, if you just realize, okay, you find out when this is turned on, this is turned off. When this is turned on, this one is turned off. So that's mean actually this 7 segment is active low, meaning that if you give 0 volt, then this one will turn on. But if you give 5 volt, then this segment is turned off. It's in contrast with your LED, because your LED is active high. Okay, it's under category active high. So active high, if you give 5 volt, it turn on. If you give 0 volt, it's turn off. I think you also learn this in digital electronic. Okay, there's a active low and active high. Okay, 7 segment is active low. Okay, you give 0 volt, it turn on. You give a 5 volt, it turn off. So of course this one is not meaningful. If you, in order for you to operate the 7 segment by yourself, you need to explore by yourself how to write a proper code where you can display some numbers here. Okay, I just turn on this segment only. I just connect one line, okay, one port only. One 2 port. When one is ground, the other is to controlling this segment, which is the A. Okay, how about your LCD monitor? Okay, LCD monitor, it's the one that the most advanced in visual output, because you can display, it's like your computer screen. You can display some text, numbers, and more interactive than the rest. Now let's go to the Tinkercad to see whether we can whether we can know how actually it's working in Tinkercad. Okay, this actually when you want to, because of course we have a lot size of LED or a lot version of LCD, so this function can be used to any LCD module that you have. But in this example, we are using 16 column 2 row LCD. Okay, if you check the size of your LCD, if you count the column 1, 2, 3, you have a 16 column, and you have 2 row, 1, 2 row. So that's why when you want to use this LCD, you need to set in this code here, begin LCD begin 16:2. Okay, that is the size of your LCD that you use in these examples. And then you just, after that, you just print hello world. Okay, by put LCD dot print hello world, it will print here. That's why you can see print hello world here. Okay, hello world. And then how actually this number is keep increasing is because, okay, at the looping part here, now before writing something, okay, before you write some things there, okay, you set the LCD dot set cursor to 01. So coordinate 01 is here. Okay, because 0 here is the column. Okay, column is 0, and then row is number 1. Okay, row number 1 means that this is row number 0, this is row number 1, and this is as well as column number 0. So you put the cursor in this location. After you put a cursor in this location, you put LCD print. You print the timer there. Okay, this is the timer. Of course, that is the timer. That's why you can see the values there. Okay. So again, you can also write anything here, because this example is too complicated for you to understand. How about we change some codes there? Okay, instead of print the timers there, how about we print something that you like? Let's say I want to print my names there. Okay, I print my names. So what happened if I run this simulation? Okay, you can see hello world, which is referred to this part again, and now this one is showing my name. Okay, so again, that is how you working with LCD LCD module. You need to set the cursor where you want to print. Of course, that set cursor, you need to give the row number and column number before you can print. By default, of course, if you don't set this coordinate, by default the column is 0 and the column is 0, the row is 0. That's why it start here. So that's why when you do print lcd.print hello world, is display here. Okay, so because by default the column is 0, the row is 0. Okay, finish about the visual output.